Alright, now this is number 18 for the midterm review packet for the universal physics. Now, this is an F equals ma problem because of the way it's worded in the question. You can look it in your packet, read the question number 18, and you'll notice that there is multiple places where forces are mentioned. Okay, there's really no indication of time, there's no indication of velocity, there's no indication of momentum, anything else. So it's kind of a clue to you that if you start seeing a lot of forces mentioned, that it should be an F equals ma problem. Okay, it really starts to narrow things down. Now, usually when you do an F equals ma problem, the first thing you need to do is draw a picture labeling the forces acting. Okay, so you can see in my picture here that I have the tension forces labeled. Okay, all three of them. I have the friction force labeled. Now the reason why the friction is east is because it does mention that the box is moving west. Okay, now since the box is moving west, friction has to oppose it. Okay, friction always opposes the motion of the object. It is always a retarding force. It always tries to slow objects down or keep objects static. Okay, and you can see here I also labeled the weight. Now this weight that I drew here actually represents the weight of everything. Everything near the Earth, the surface of the Earth, has a weight equal to its mass times gravity. Now try not to confuse mass and weight. Mass is the amount of matter that makes up an object, measured in kilograms, and weight is the amount of force pulling it down towards the Earth. Okay, so they are different things. One is a force and one is not. Now, the first part, part A, it's asking you to find the horizontal acceleration. Okay, so we look down here, we're asked to find the horizontal acceleration. Now, a key thing to remember is that only horizontal quantities affect horizontal quantities. They are separate from vertical. Okay, so you can see that, like, for example, T3 is a vertical force. Weight is a vertical force. Okay, as you look down here, you notice that I didn't include those in a question about the horizontal movement. Okay, only T1, T2, and friction are used. Now the reason why T1 is positive and added on the FNet side is because that's what's driving it west. T2 and FF, if you notice, are against the motion. See how the arrow pointing for the motion is to the left and these are to the right, so they are retarding forces that oppose it, trying to hold it back. Okay. Now you're looking for the acceleration given the mass. Now you have to consider what mass is accelerating. It's not just the 1,000-kilogram crate, but it's all three objects. That's why if you look here, this mass that I have written in the work is 1,160 because it's the addition of all three. Now you get an answer of negative 0.086 meters per second squared. Now because you made T1 positive, west has become the positive direction. Usually the direction of motion is the positive direction. So since you got a negative, that means that you have a negative acceleration pointing east. Now that doesn't mean that the acceleration is, that doesn't mean that it's moving east. That means that the acceleration is east. Okay, so in reality the object is still moving west, okay, but it's slowing down. Now you know that it's slowing down because of the fact that you have a opposing acceleration for the object. Alright, so that's part A. And again, remember that vertical only affects vertical and horizontal only affects horizontal. Now in part B, the question is asking you, does the box lift off of the crate? Now in order to understand whether it lifts off or not, you have to understand a balance, or the difference between balance and imbalance of forces. Okay, when you have more force in one direction than another, then you'll have an imbalance and objects will accelerate and change what they're doing. Okay, so in order to lift that 70-kilogram box off of the crate, you have to apply more force up than what's applied down to it. Now, the force that's pulling down on it is its own weight. Okay, there's the weight of this 70-kilogram box is what's pulling down on it. Okay, so if you first understand what the weight of the box is, 686 newtons,
you know that you have to pull up with more than that in order to get it up. Now it says in the question that you're only pulling up with 586 newtons, so you're not putting more up than down. Okay, because you're not putting more up, not putting more up than down, it's not moving up. Okay, it's actually staying where it is. Okay, to lift anything off a surface like that, you need to apply more force up than down, which usually means more than the weight. Now part C, it's asking you to find how much force is the box exerting on the crate and the crate exerting on the box. Okay, which should be the same thing. Now because it's not moving, it's balanced, which means there are the same number of forces up as down. Okay, so you know that you didn't pull up with enough tension to pick the box up. Okay, so the box is not moving vertically, which means the forces that are up equal the forces that are down because there is no acceleration. Okay, if you go back to an F equals ma formula and you put in an acceleration of 0, that means the net force equals 0, which means up minus down equals 0, which means up equals down. Okay, so you have to think about, okay, now what is acting up? Okay, what's acting up is the tension in the cord that's attached to the ceiling and the fact that the crate underneath it is pushing up. Okay, so we're trying to find out how much is the crate pushing underneath it. Those two have to be equal to what's down, and the only thing that's pushing down on it is the weight of it. Okay, so the weight of that box is still pushing down, and it's balanced by the tension in the string and the normal force. Okay, so that means the tension, T3, plus the normal force equals the weight. If you notice, there are no horizontal forces acting in this question because we're not talking about a horizontal situation, but a vertical one. Okay? Now part D, I kind of explained already, because contact forces are equal and opposite. Okay? If you are 150 pounds and you're sitting on your chair, the chair is exerting 150 pounds on you while you're exerting 150 pounds on it. So the force on the crate is the same as the force on the table. That's a Newton's third law problem. For every action, there's an equal and opposite reaction. Okay, so in part C, you found that there's 100 newtons up on the box. That means that there is an equal 100 newtons down on the crate. Okay, now part D, well, I'm sorry, that should be part, excuse me, this should say part E. I messed up right there. Okay, now in part E, they're asking you to find the force exerted on the crate by the floor. Okay, now since it's not moving vertically, again, nothing's moving vertically, the forces up are equal to the forces down. Okay, so let's think about what's acting down on the floor. Okay, the weight of everything is acting down. Okay, that's why I wrote weight total. You'll see it in the work. Okay, the crate is pushing down on the floor, making contact force, and also because there is a person and a box on top of it, they're both pushing down on it. I want you to think of, if you just sit on the floor, there's so much contact force between the floor and you. Now, if somebody were to push down straight down on your shoulders, you would feel more force on the floor because there's more force pushing down, which means it has to counteract it with more force up. Okay? Now let's think about what forces are up. The floor is pushing up on everything. And also you got to remember you're pulling up with 586 newtons from the third tension, from that string that comes from the ceiling. Okay? So really, the weight total is down, and T3 and the normal force from the floor is up. Okay? And you're trying to find the normal force or the contact force from the floor. So you do your algebra, you isolate n, because that's your variable, and you solve for n. Now just remember, you have to include the weight of everything. Okay? It's the weight of everything. And you can do all of this because you notice that E equals 0, because nothing is moving vertically. Okay, now that's a pretty loaded question, but if you start really picking it apart, remember to take out the key things. weight is different than mass. Okay, weight is a force, mass is not. Horizontal quantities only affect horizontal. If you go back and you look at all the things that I've done, part A, B, C, D, and then this one that was mismarked, it should be part E. There's nothing where you see horizontal and vertical mixed. They're completely separated. Okay, and that's true of all vectors, and you'll see that more and more this year. And then when you take IB physics with myself. Now, another thing to remember is the difference between positive and negatives. Positive and negative shows opposition of direction. Okay, so you notice in the first question, part A, object is moving west. You get a negative value for acceleration, means it's moving east, the opposite way. Okay, and that tells you something. In part C, T3 and N are up. The weight is down, and you notice that they would oppose each other. Okay, they have opposite signs. Okay, you can see the same thing down here. T3 and N are in the same direction, so they're both positive. Okay, so I would go over this again, see what you can find. This is a tough question. Okay, this is a very loaded question, but it's not out of anybody's range of ability. Okay, I'm going to try and set up a few more of these so that you have them before your test on Wednesday. Okay.